right. Thanks, Michelle. Appreciate the intro. And yeah, looking forward to our topics today. So quick reminder, like Michelle mentioned, everything that I'm going to show today, and there'll be a bunch of links into GitHub repos, is 100% open source. So do check it out. We'd love to have your feedback. And if you are liking what you're seeing, we'd always appreciate a star. Just real quick, you're here because you've probably heard about FiftyOne. And what is that? Well, FiftyOne is an open source data-centric ML solution designed to help you organize your unstructured data, visualize it, identify key weaknesses in your data sets, and integrate it deeply into your ML workflows with the goal of helping you build higher quality data sets, because that's going to be one of the best ways to improve the performance of a machine learning model. Graphically, the way we think of it, FiftyOne is like the glue between your data and your models. So you may have tools in your stack for getting data annotated. On the other end of the spectrum, you may have tools to train models and deploy them into production. What FiftyOne provides is basically a single source of truth to help you organize those data, integrate with your annotation tools to get those data annotated, integrate in the other direction with your model training frameworks to train models on those data sets, and then providing you workflows to build feedback loops to curate higher quality data sets and use some of the tools in FiftyOne to identify those weaknesses, answer questions like what data should I be annotating, what data do I need more of, what can I do to improve my model's performance. FiftyOne is an open source framework that makes that happen. And today, we're going to talk about some interesting new features with that. But once again, we focus on visual data today. So that means images, video, classification, object detection, all the different task types that you likely work with if you do computer vision. FiftyOne is supporting those today. And if there's something that's missing, do let us know in our Slack community on GitHub, and we will get right on that, because our goal is to basically support every type of workflow that you could imagine for unstructured data, with a focus today on images and video, and broadening that focus in the future with new types every day. So in case you missed it, we announced a really exciting new feature we're calling VoxelGPT in the last week or so. So let's start by talking about that. And I think the best way to understand what VoxelGPT is really just to watch it in action. So we're calling VoxelGPT your AI assistant for computer vision. What does that mean? Well, it's providing, as the name GPT implies, a chat-based interface to allow you to ask questions about your data sets, the FiftyOne documentation, and even general computer vision knowledge directly in the FiftyOne app. So here's a little example. We'll do a live demo in a second. FiftyOne now has a chat interface you can open up, and you can go over there and you could ask questions. In this case, we first asked a question that resulted in loading a view into the data set directly in the app. Here's a follow-up question that's appending to that previous query to say, hey, within that view, I'm interested in this particular type of object. You can see that VoxelGPT understood what was being asked and automatically constructed the corresponding Python code to load that view in the app. Super cool. But it can also do more than that. So like I mentioned before, it also understands the FiftyOne documentation. So here's an example of a question where in the context of that conversation that was being had with the data set, the question arose, hey, what's that F I saw in the Python code? VoxelGPT understands the FiftyOne documentation. And if you ask a question like that, it can go search the docs and pull back a summary of what it was that you were asking, with even citing its references. So you can click through and find those. And here's an example of one final capability in VoxelGPT. If you ask something that's more of a general machine learning or computer vision knowledge question, it'll understand that too. And it can pull an answer to that question and present it to you, again, right in the FiftyOne app. So a couple key action items from this. First of all, if you want to try VoxelGPT for yourself, that's super easy. Let's do it together right now. All you have to do is just go to gpt.51.ai and you can try it out yourself. So I will do that. So when you hit this website, you're presented with that exact interface that we were just watching. So I've got a data set here on the left. This is some some data from Cocoa. It has some ground truth object detections. It has some model predictions from YOLO Nas. And then we've got the VoxelGPT panel on the right. When you log in, it'll be open just like this. So you can just drop in and start exploring. So here we can see some example prompts that we can try. So for example, if we were interested in seeing, can I export this data set in Cocoa format? We can issue that query. And what VoxelGPT is doing is understanding what type of question were you asking. In this case, it identified that, hey, the 51 documentation has some examples of how to export in Cocoa format. So it's just pulling in that information for you. We can see some code snippets. Again, some links to documentation there, all right at your fingertips. We can also try maybe one that loads a view. So here we're saying, hey, show me the samples with high confidence predictions that were evaluated as false positive. So this one's a little bit more complex. You can see that VoxelGPT is kind of telling you what it's thinking. The first thing it did is it identified that you might be referring to a couple algorithms that 51 supports. 51 has a notion of mistakenness. It also has a notion of evaluating models. So it identified that. It checked the dataset schema and found that indeed this dataset has had a mistakenness method ran on it. It has had an evaluation run. It found the name of that evaluation run on the dataset. And furthermore, it identified that there's also some relevant fields on the dataset that may have information of interest. And so it pieced all that together and it ended up loading a view, which did what we said. It converted to evaluation patches where each sample in the grid here contains either a false positive, a matched true positive, or a false negative. And then because we were asking specifically about false positives, it pulled out just the false positives. And then because we said high confidence, it picked a threshold of 0.8, packaged all that together. And here on the left, we're seeing high confidence, false positive predictions. So pretty cool stuff. Just for fun, we can try another type of query. So we saw a docs query. That was what I was calling a view query. Maybe I want to just say, hey, explain computer vision in one sentence. Try that too. VoxelGPT will figure out that you're just kind of asking a general knowledge question and put together an answer for that. So again, if you want to try this for yourself, you can check it out, gpt.51.ai. And like I mentioned, everything in this talk is open source. And so you can find the code for VoxelGPT at this repo here, voxel51/VoxelGPT. So do check it out. So I want to share with you a little bit about how we built the internals of VoxelGPT. So we kind of talked through the three different pathways that it understands. It knows how to query the 51 docs. It knows how to construct views into your data sets. And it knows how to answer general CV knowledge questions. And so how we structured this, well, a user query comes in. The first two steps in the pipeline, we do a quick call to OpenAI's moderation endpoint to make sure that there's nothing not safe for work or otherwise unsavory in the query. If something's found, it'll just immediately return and do nothing. If the query is good to go, it passes through to an intent classifier. In fact, there's some interesting design decisions that we made in this diagram here. Obviously, there's other ways that systems could be built and new capabilities coming every day to sort of automate certain pieces of this, propose different architectures for this kind of decision-making in general. We actually wrote a couple blog posts about how we built VoxelGPT and the various adventures in prompt engineering that we went through. You can check those out actually in the links in chat if you're interested. But anyways, where we wound up was with this sort of decision tree here, where we first analyzed the query. and try to understand which of the three pathways we think the user's query most likely falls into. So if we think that it's a question that the 51 docs can answer, the way that that was implemented, so we took the docs, we tokenized everything, we embedded the documentation using a text embedding model, and basically fed all of those into a vector database so that when a query comes in, we can tokenize that and do a nearest neighbor search against the documentation to basically pull in some relevant sections of the documentation and then package those up into a prompt, a prompt of the form, hey, you're a computer vision expert. Your task is to summarize an answer to the user's question, given this context from the 51 documentation. And then we'll feed in some of the best matches and ask GPT-3 to spit back a sort of summarized response with citations and even with some incentives to prefer code snippets when possible to make the responses more actionable. Now, and another pathway that it could go down is the view query, where we've interpreted that the user is likely asking, hey, I'm looking at a data set right now. I want to see a particular view into my data set, which is 51's term for searching the data set to pull out a specific subset. So the way that we handle that is basically by passing the view query through a sort of example mining procedure where we pull in a bunch of example queries. We basically have a very long list of valid view expressions in 51's language. And then based on the user's query, we select a context of relevant examples and then feed those in a similar way to the docs query into GPT 3.5, asking it to basically generalize what it's learned about how 51's view expression language works, and basically translate the user's query into a localized version of the examples that it was fed. Definitely not 100% perfect. There's a fair amount of trial and error in there, but it is a relatively general approach that was wicked fun to build and also has the potential to be continually improved through better engineering of prompts. And then the third pathway is queries that were interpreted as being just general knowledge CV questions. So that pathway is actually pretty simple. We actually just construct a prompt for GPT 3.5 explaining that the user is asking a question and your goal is to educate them about the answer to that question while trying to connect it to 51 in general, since to make it actionable for our users, it's likely that they want some information specifically in the context of how 51 can help. So that prompt gets engineered, fed to GPT 3.5, and then those responses get streamed back. So again, if you want to know more about the particulars about how VoxelGPT was implemented, we've got some blog posts in the chat. And of course, the code's open source, so you can check it all out and see every last detail. So now I want to do what might at first seem like a pivot into something completely unrelated, but we'll see about that in a minute. And that is a new feature called operators that was released in the latest version of 51, which is part of the plugins framework that has existed for a few releases, but with operators, you'll see has gotten a significant upgrade that I would love to tell you more about. So as a reminder, 51 has a plugin framework. And that plugin framework is basically designed so that you as a user of 51 can extend and customize its functionality in already a variety of ways and only increasing over time. So as an example, you can use plugins to build custom panels that appear in the 51 app. You can build custom visualizers that render information about samples, images, and videos and their labels in your data sets. You can do things like configure that certain pieces of code should run when the app starts, or for example, place custom icons in the app to give users entry points into that custom functionality that you built. But now with 51, the .21 release, the most recent version, we've added a whole new component to plugins that we're calling operators. So operators are concept of sort of logical piece, an operation, a logical unit of code that takes inputs, performs some computation, and returns outputs. So in the context of plugins, a plugin is basically a container for a variety of different things. Plugins can contain components of various types, like panels, and then they can contain one or more operators. Operators can be written in Python or JavaScript, and these pieces can interact with each other through a message passing mechanism. It may sound complex at first, but we're actually going to spend most of the rest of this discussion seeing how operators can be used in practice, because they're really quite powerful and easy to write. So just a few more words about operators. Again, operators are brand new in the .21 release. So if you want to use them, definitely upgrade your 51 package. And what you'll find actually, so in this GIF here, we're seeing a new feature that exists in the UI to expose operators. So if you click this button here, it pulls up sort of a spotlight where you can search among all of the operators that you've installed on your 51 deployment. As a matter of point of order, there's a bunch of built-in operators that already exist. And so if you just upgrade 51, you click that button, you'll see a bunch of operators already there. But since operators live within plugins and you can install and write custom plugins, you can basically have complete control over what you see in that list. In any case, in the UI here, we're seeing how an operator is used. So like I mentioned, operators are logical units of code that take inputs. So here we can see once that operator was chosen, in this case, renaming a sample field, it has basically a dynamic form that can be used to provide inputs to the operator, and then an execute button that will execute that logical unit of code given the inputs that the user provided. And importantly, like you're seeing here, do things that modify the data in the data set, but also trigger other actions, for example, refreshing the app, opening a panel, clearing the view. Basically, all of the sort of hooks into functionality in the app are available to operators so that they can trigger them. And so as you can see, it's really a pretty powerful way to perform highly customized operations. Basically, with operators, you can pull up a Python interpreter, write a few lines of code, and place, again, with no front-end knowledge whatsoever, place a new button in the app and give yourself the ability to perform a completely custom action within the app. Couple features to do with operators that we'll see actually in action later. Like I said, operators accept inputs, but there's a rich type system that exists in the 51 framework built in to give you the language to describe all the different types of user input you'd like. You can create drop-downs, radio buttons, drop zones, progress bars. We'll see many of those things later. All of those components are built in, and so using those components is basically just one line of code. We were seeing an example here of an operator that is what we're calling dynamic. That means that as the user provides inputs, the form can change. It can reveal new fields. It can completely rewrite itself. The inputs can be dynamic, and so you can build quite complex user input flows. Again, with no 0 lines of front-end code, all configured through a simple Python interface. And like we were seeing with VoxelGPT, operators can also stream results back. So that unit of execution doesn't have to just be synchronous. It can be asynchronous, and it can also generate outputs rather than returning one chunk of output. And importantly, like I mentioned, plugins are something that you can write yourself and install in your 51 deployment. We'll see how in a second. There are some built-in operators, as an example, that live built into the 51 app, so you'll be able to see those always. But you can also download and install other plugins. So we at Voxel51 have started a new repository called 51 plugins, which is basically a curated collection of plugins that we've built or users have contributed that are sort of organized by type. So those things are useful because you can you can just browse there and see if there's a new functionality that you want to have. You could also use them as examples. Again, this repository is open source. You could use it as an example pattern to build your own operator or plugin, or contribute one yourself. Contributions would be welcome. So like I mentioned, plugins are very easy to install. Again, this is functionality that exists only in the latest version 21 of 51. So do upgrade if you want to try it out. A lot of the plugin related matters are most easily accessible through the CLI. So you can run commands like downloading a plugin, listing the plugins that you have already downloaded, listing the operators that exist within those plugins, and then do things like enable and disable individual plugins. If you, for example, want to have the code locally, but don't want that particular feature enabled at that time. Now, perhaps you saw the connection. We talked about VoxelGPT, we pivoted to plugins, but there's been some breadcrumbs along the way. VoxelGPT is a panel within the 51 app. Here we're seeing a command that seems to indicate that you can download VoxelGPT as a plugin. And so the answer is yes, VoxelGPT is a plugin. So what does that mean for you? Well, it means if you want to install it yourself, you can do that. So if you want to work with it locally, you can just run this command here to download it as a plugin. If you haven't written this down, you can just go to the repo. Of course, it'll show you how to install it locally. But yes, VoxelGPT is a plugin. And so if we think back to the architecture of plugins, we can do some comparison to see sort of how the pieces of VoxelGPT fit into the plugin framework. So in VoxelGPT, there is a panel. In our case, it's a panel that shows a chat history. So in the code, that's called chat panel. And then there's basically a set of operators that do the underlying functionality. So first thing that happens is the panel accepts user input. And then when that user input has been received, the panel triggers an operator to send a message to the backend. The backend is implemented, surprise, surprise, as an operator. And so that operator wakes up, it retrieves the user input, and then it interacts with the sort of backend VoxelGPT system. So basically, you can think of this as a black box. Operators give you just an entry point to run arbitrary code within your plugin system, given the inputs that were provided to it by the plugin interface. So VoxelGPT does its thing. It runs some queries to vector DBs, to OpenAI. Like I mentioned, operators can be streaming. And so as the backend is doing its thing, it returns bits of information back to the user, maybe some breadcrumbs about its thought process, or a streaming output once it's just connected to an LLM and pulling back responses. So that information gets streamed back to the front end. Those streaming content are received by another operator called show message, which interprets the input from the backend and displays it in the panel. So you can see that even something that seems like a full-fledged application, and is a full-fledged application, can easily be represented using a VoxelGPT plugin architecture here. So hopefully that will give you a sense of how you could perhaps pattern match and insert your own capabilities into the context of a plugin. This is probably too detailed for this conversation, but I believe you'll have access to the slides later. This kind of shows every interesting bit of the code to implement VoxelGPT. So on the right, we have the components that were in the JavaScript section of the plugin. And on the left, we have the Python. So for example, on the Python side, there was an operator called ask VoxelGPT. So we can see that here's the definition of that operator. When you define an operator, you basically configure its name and you provide the details like, hey, this operator is one that when you execute it, it should be called as a generator because it's going to yield responses back rather than performing computation and returning a batch of results at the end. So that's how that's specified. And then in this case, this operator is used programmatically by another operator. And so there's simply nothing but an execute method that retrieves from its execution context any parameters that were provided to it. It can then do its computation, accessing things like the current view that exists in the app in case that's needed to perform the computation. Obviously, many operations in 51 do use views or datasets more generally because that's the whole point. 51 is a dataset management tool, but it's not required. Operations could do other things. For example, they could ingest data or create or destroy datasets. But in any case, that operator then makes a call out to the backend VoxelGPT implementation, and then basically we're in like your custom code here territory. And then the point is that when you want to interact back with the rest of the system, you simply trigger other operations. So in this case, like I mentioned, there's an operator called show message. And so once that bit of information, once we have a bit of information that we want to send back as a response, we can simply trigger that custom operator that we defined over here in JavaScript and provide it the message. Or if we've done something and we now want to load a new view in the app, that's amazingly simple because there are a set of built-in operators that already exist. For example, set view here that will allow you to update the app state by setting the view to a new view. So there's essentially built-in operators that exist already to do all of the state mutation operations that you may want to do in the app. You can set the data set the view, reload the app, open the samples modal, clear the view bar, refresh. There's all kinds of built-in operations that already exist, and we'll be adding more. But you can see the ability of operators to trigger other operations as a very powerful pattern that helps write simple but powerful code. On the JavaScript side, I won't dwell on the details too much, but like I mentioned, there is a panel that gets displayed in the 51 app. So panel is a concept in 51. And so when you are declaring your custom React component, you specify that you are providing a panel, which has an interface implicit with it. This encodes like where it should appear and how it should be opened and so forth. But basically, it's a place for you to put custom React code. You can use things like Material UI, which is built in natively to 51, to build beautiful UIs with minimal effort. And then similar to the Python operators that we built to do the backend functionality, VoxelGPT declares those JavaScript operators that we mentioned here to do the two-way communication of sending messages to the backend and then parsing those messages when they come back. So again, operators and panels got grouped together into a plugin. And then just with this relatively small amount of code, you can build quite a sophisticated custom functionality directly in 51. So we've been talking relatively concrete, but now I want to get very concrete. So if you're out there in the audience saying, hey, this is great, I like 51, I find it very helpful for my data wrangling, data set management, model training, pipeline building, insert your use case. But I don't know much about writing JavaScript. What I know about is writing Python. I want to do a deep dive into building Python operators to give you a sense of what in practice it would look like to add some new functionality to 51. So to do that, I want to point us to a couple operators that are in the 51 plugins repo. So here we've got the 51 plugins repo, and basically the code that I'm showing here is in a plugin called the IO plugin. And this IO plugin has two operators that we're going to look at today, one called add samples and one called export samples. So as the names imply, these are operators that are going to allow you to do things, IO things in the app rather than code. So let's just see how it works first, shall we? So I have 51 installed locally. Actually, I should show 51 plugins list. Let's see what plugins I have installed. So you see I have VoxelGPT installed. I also have the IO plugins that we just talked about, or the plugin installed. I can also list to see what operators I have within those plugins. You see I have some other plugins too, but they're not enabled. So I won't see those plugins or their operators in the app. So here's a bunch of operators that I've installed that live within these plugins. And so in particular, you see that we have the add samples operator and the export samples operator enabled. And so since those are operators, what that means is that when I open the app and then load a data set, in this case, I'll just load an empty data set. If I now use the browse operations action, I will see these operations are sorted by recently used, actually. So you can see that I've used add samples and export samples recently. So they're right at the top. In general, you can do a search to find specific operators. I should also mention that that might be the last time I use my mouse in this demo, because operators are designed to be things that you could use very quickly. So rather than clicking the browse operations button, I could instead push backtick, sort of Mac Spotlight style, to open up this operation menu. And then I can immediately start typing. I can also mouse or key through the different operators. So it's designed to be something that you could use very quickly. So let's try the add samples operator first, and then we'll talk about how it was built. So it's presenting a choice. I can pick a directory or a glob pattern. So let's try a directory first. So here I've provided a directory, and you can see that it's done some validation on that directory and said, hey, I found 5,000 files inside that directory. So seems reasonable. We can click execute, and we see a progress bar, and then the app refreshes, and now we have those 5,000 samples in our data set. We can try the other variation real quick. Let me I deleted all the samples from my data set. I'll refresh the app. Press backtick to open operations. Add samples is up top because I just ran it. Let's try the glob pattern instead. So in this case, oh boy. Add samples, glob pattern. So here I have this directory. This glob pattern matches one thing. If I, for example, type PNG star PNG, you can see that it's telling me that, hey, no files matched, and so I can't execute the operator. If I change it to star JPEG, you can see that, hey, I found those 5,000 files. Now I can push execute. By the way, in this particular case, we could have used a file explorer built-in component, but I want to illustrate some of those details, like the error states and the notice messages, because I want to show how you can build your own states into your operators. So in any case, in this case, I did a glob pattern. It found the same 5,000 files. I can push execute, and I get the same effect. But notice that that form was dynamic because I got to choose, do I want to provide a directory as input, or do I want to provide a glob pattern? And both resulted in the same outcome. So the code for that operator is here on the right. So let's just talk through it and get a sense for what is happening. So I'll open add samples. So when an operator is started, basically what happens is the resolve input function gets called. So the task of the resolve input function is to take the context object that's provided to it. The context represents all of the information that this operator is allowed to have access to. So you'll see if we peruse some of the code, context has things like params. Those are the parameters that have either been already specified. We'll talk about how they could be already specified since the form is blank, but parameters can already be specified. And then the task of the resolve input is to define the properties that represent the UI elements that we want to present to the user. So in this case, you can see the choice between directory and glob pattern. That's happening because I made an input, which is an enum, and I'm specifying that it should have two choices. It should have an enum value called directory, which is displayed to the user as directory, and another choice that I'm calling glob pattern internally that's showed to the user as glob pattern. And then I'm sort of constructing, the syntax here is basically adding this property to the inputs so that when this function finishes executing and control returns to the app, it will have a description of the inputs that includes this enum property, which is being rendered to the user using a radio group view. So just pausing on the terminology there. So operators have properties that define, allow the user to configure the parameter values. And those properties, you can control the way they're displayed to the user. So here we're using the built-in radio group type, but you could have used a dropdown instead. We'll see an example of that later. But the point is that here we're specifying completely in Python in just a few lines of code that we want to have a radio group selector. So here's where things get interesting. This whole function here implements all of the functionality in this UI. So how do all those responsive things happen? How come when I click glob pattern, this input changes and then it shows that it's required, the execute button is grayed out? How did I configure all that? When I type a path, it figures out, it performs some computation and it shows that there's 5,000 matches. How did that happen? Well, that's actually all specified in this code here. And so the key thing to know about operators, this one is an example of what we call a dynamic operator. Dynamic means this resolve input function should get called multiple times until the user clicks execute. And so in code, the way to understand what's happening is that the resolve input function, it takes the current state of the parameters and it passes them through some logic that you get to use to define, okay, based on the current state of the parameters, I now need to provide these user inputs or these form inputs to accept more user input. And then, as you can see, you can implement arbitrary control flow here. You can do if statements, for loops, you can wait, you can do some computation. All of those things are possible. I should mention that operator execution has a strict timeout policy. And so if you are wanting to run some computation that takes longer than, let's say, 30 seconds, it's not going to be a good fit to directly and synchronously execute within the operator. If you want to do something long running, we'll get back to that in a second. It's definitely within scope of operators, but you don't just run it synchronously in this function or in the execute function either. Okay, so here what we're saying basically is there's this concept of a radio button. The user gets to interact with it to choose between these two options. If the user hasn't yet interacted with it, we're specifying a default value. That's here. And then as the user interacts with that form, basically, because this property is called style, the value of that form will be inserted into the style parameter in the context. And so you can see we're defining the user input. And then here we're just accessing like the current state of the operator. And so that's where we get this ability to write logic like, hey, if the user has selected directory, then let's make a new input. This one will be a string. That's what this form input field is. If they've provided, well, first of all, we're marking it as required, which means if this property has no value, then basically the operator framework will go ahead and mark it as invalid. If there's a required property on the inputs that doesn't have a value, then mark the inputs as invalid. You can't click execute. Now, if the user has provided a directory, we can then write our own custom code. In this case, we go ahead and just do a glob match on the user's file system to see what matched. And then depending on what we found, we can do more custom things. So here's the logic that says, hey, if the directory was valid and there are at least one matching file, then go ahead and update the caption of that form input to say, hey, I found 5,000 files. Or if there were no files, go ahead and mark the property as invalid, which disables execute, and then provide a custom message to the user. So you can see that that's just a small amount of code provides all that context for how this form should work. So from there, the glob pattern choice is completely identical. Grab a user input based on the value, the computation that you find, go ahead and render some information. Okay, so this defines the inputs that the form takes. And if the form is in a valid state, the user is then allowed to push execute. And like we saw before, when you push execute, in our case, we're adding some samples to the data set, and we're showing a progress bar to track the progress. So actually all of that is implemented right here. And so basically what happens, well, the execute method is called. We grab the parameter values that the user provided in the inputs. In this case, they provided either a directory or a glob pattern. If nothing matched, we just return and do nothing. Now, if something did match, we have a list of file paths, and we want to create new samples and add them to the data set. So obviously, that is quite simple with the FiftyOne SDK. All you have to do is create some sample objects and call add samples. And so the real power of FiftyOne operators is that you can just do that. You can write any arbitrary code that you've written. Maybe you have a directory of like 51 scripts that probably contains 51 scripts with your 51 different workflows. Now you can wrap each of those workflows into an operator and give yourself a button and a custom dynamic form to execute those operations. So in this case, just to make it more usable for the user, we wanted to show a progress bar. So the way that progress bar works, well, you can see this thing here called progress. That's obviously important. The second important component is that if you want the execute method to sort of generate intermediate outputs, then when you're defining your operator, you need to say that it should execute as a generator. That means that when execute runs, it's not a function call, it's a generator call. And so it doesn't just return things, it also yields things. And so here what we're doing is splitting up the file paths into batches, and then adding a small batch of samples to the data set, and then triggering an operator in a built-in operator in FiftyOne that will show some value. And so the power of operators is that I get to specify how that value should get rendered. So I'm saying, hey, I have a value, it's a floating point value, it's progress, but I want it to be presented to the user as a progress bar. And so FiftyOne contains a built-in progress view type. And so all you do is use that type. This specifies how it should be presented in the UI. And then you simply provide the value at runtime of that progress. In this case, our progress is the number of samples we've added so far divided by the total number. And so that's how you can see a progress of 0.7 or something, 70%, depending on the number of samples that have passed through. And then, like I mentioned, operators can trigger other actions, built-in actions in the app. So here, we added a bunch of samples to the data set. We'd like the app to update to show, reflect that the data set has more data in it. And so that's as simple as calling the built-in reload dataset operator. I see that a question just came in. Let me take a look at that real quick. Yeah, so question about how do you debug operators? So as a matter of fact, I might as well do it right now, right? Here, I just edited the code, and now when I click add samples, I see the new value. So operators are sort of hot reloading, similar to if you're an app developer or something. So it's actually very straightforward to literally write an entire operator and test it from soup to nuts without closing the app. And then there's a follow-up question about would FiftyOne work like if you're running the app in a PyCharm ID or something like that. I don't personally do it. I mean, what I'm showing here is how I normally work with FiftyOne. I know that users use things like VS Code and so forth. And so it is possible to launch the app through a VS Code debugger or something. I believe that it does get a little finicky sometimes. So at least in this context, I would argue that launching the app outside of the debugger is a nice way to ensure that things don't reload when you don't want them to. But yeah, good question. So I want to just quickly show one more operator and maybe talk about it for a few minutes. So in that example, we were adding samples to a data set. Let's do something a little bit more complicated. So here, I already have a data set. I've loaded the data set in the app. And now I know that I can export that data set through code. But I want to export it from the app, because why not? So that's what the export samples operation enables. You see, first it's asking me to pick what I want to do. So I can export, I have some choices. I can export only the file paths. I can export the media, only the labels, or both. So maybe I'll do labels only. Now it's saying, hey, you need to pick a label format. So it's presenting some options here. It seems smart because my data set has object detections. So it's showing me relevant formats like Cocoa and not irrelevant formats like some classification format. So I can pick Cocoa. Now it's seen that I picked a labeled dataset format that takes object detections, but FiftyOne datasets have flexible schemas. I got to pick a field. So I can do that. And you can see that it's intelligently showing me, hey, in your data set, you've got two fields that would work with this type. So I can pick ground truth. And then it's telling me, hey, you got to pick a location to export. So I can type a directory. Here it's saying, hey, that directory already exists. Do you want to override it? And if I say, no, I don't want to override it, it will put the modal into an error state and not let me execute. Or I can pick something that does exist, and you can see that it's displaying an informational notice to me about how big this export will be. And then I can run it. And it has completed, and it's telling me that 200 samples were exported into this location. So just real quick, there's obviously a little bit more logic in that flow, but I want to show you how that code looks. So that's in the same file. Again, this file is available in the FiftyOne plugins GitHub repository under plugins IO. So here's the operator. The inputs are a little bit more complicated, but not too much. So actually, I missed one other fancy thing. Let me do a filter first. So I'm not interested in exporting everything. I only want people. So I did a filter to do people, but then I don't want all people. I'm just into sports right now. I got excited by the French Open. Let me just do this one sample with tennis players and maybe a baseball as well. Now, if I run the export samples operator, there was another choice presented to me. Do I want to export only what's selected, only the current view I'm looking at, or the entire data set? So again, if I just go through the process and pick the fields and get myself to an export location, you can see that if I export the entire data set, it'd be 270K. If I only export the current view, it'd be 90K. And if I only export the current samples, it's 1,000 bytes. So this is an example of sort of more of the context object that exists in FiftyOne, or in the operator execution environment. And so we can see in the code here how that works. So the very first thing that we're doing when building the input form is we're deciding, hey, what are we dealing with right now? Is the user's view basically different than the whole data set? If it is, then we want to give them the choice of whether they want to export only the current view or the entire data set. If they've also selected some samples, context.selected represents what has been selected in the app. If they've selected some things, then, hey, we want to add a choice to let you pick only the selected samples. So you can see that we're sort of like contextually building up those choices. The reason that those choices didn't appear at all in my previous example is because there was no view and there was no selected. And so I just completely skipped over that whole path and then basically said, you know what, I don't even need a UI element to grab that parameter from the user. I'll just go ahead and set the parameter myself to a default value. And so you can kind of bypass entire UI elements. In any case, once they've picked what they want to operate on, then we basically keep chaining those operations. So in the interest of time, I'll go through this quickly. So basically, no matter what the current view is, the first step is always again, this was our choice. Our first step was let the user pick what they want to export among these 4 choices. So you can see how that's implemented in the code here. And it's saying that, hey, the user must choose one of these. So if they haven't interacted with that input, then invalidate the whole thing. Don't let them do anything else. Now, remember that since forms don't have to have values, when you're writing the rest of the operator function, you have to account for that. And so the function of this property is to populate the parameter called export type. And so if the user hasn't interacted with the property, that export type might not exist. Of course, if I wanted to make it exist, I could provide a default value here. I could, for example, say labels only, and that would correspond to picking the labels only option by default, in which case I could implement the rest of my code knowing that parameters or the export type parameter would exist. But in any case, so I've gotten the export type from the user, and then I just contextually decide, okay, we have a concept of labels only export or media and labels. And so, hey, they're talking about labeled data sets. Let's run some arbitrary 51 Python code to figure out what are some appropriate dataset types that would exist. And so just to give you a sense, like now we're just looking into how you would write code that uses the 51 library, but we're taking the current view and we're saying, hey, let's get all of the, what are we doing here? We're getting all of the fields. We're saying, hey, in my data set, look through its schema and find all of the label fields and then get their types. And then we've basically hard coded down here the different types we want our operator to support. And we've specified which ones are classification types, detection types, and so on. You can imagine, I won't bore you with the details, that allows us to intelligently populate this dropdown with export formats that are appropriate for the actual current data set that's being worked on. So there would never be invalid formats here. So that happens. And then the user now needs to pick, okay, I picked Cocoa format, but now I have to pick the right label field. And so a very similar logic happens where basically the user has to specify what, if they've chosen a dataset type that requires label fields, then go ahead and build some more UI to request the label field from the user. Finally, request the export directory from them. Here's the logic, which was somewhat sophisticated, right? But just a couple lines of code where we're checking to make sure that the directory doesn't already exist. So if it already exists, then render a new checkbox. And if that checkbox is set to false, this checkbox, again, just to talk through the way the flow works, I want a value to be accessible to me called overwrite. And so I create a property, and then I want it to be presented to the user as a checkbox. So I specify that it should be using the checkbox view built-in type. I get the value of that parameter, which either takes into account the default value or the value that the user has provided when at the current time when this function runs. And then I can do things like say, hey, if it's false, that's the user saying, ooh, I don't want to overwrite this directory, so go ahead and invalidate the form. But it's completely optional. If that code path isn't taken, that checkbox just doesn't exist. And then finally, we have the export size. So again, it's a cool capability, and you can implement that in just a few lines of code. You basically take the current view, run your function to estimate how big the export would be. We won't talk about how that was implemented. It's a heuristic. And then basically display to the user a notice. Again, there's a built-in sort of design language. And so you have at your fingertips things like error messages, notices, information panels, blah, blah, blah. In this case, we're showing to the user how big the export is. And obviously, if we wanted to implement a export limitation, you could do something like say, hey, if the estimated export size is greater than some value, set the property to invalid, and then the user wouldn't be able to execute unless it was within that limit. Okay, so ran a little bit over time. So I'll just kind of wrap things up real quick. But hopefully what we've covered here will kind of whet your appetite on how, if you know a little bit of 51 Python, if you've got a little bit of that lingo under your tool belt, you can now build quite complex custom forms in 51. And here we were showing some simple examples of input-output, but really these custom operations can be quite various. Maybe the execute method, it doesn't do anything synchronously. Maybe what it does is it schedules a task on your external orchestration tool like Airflow. Or maybe it interacts with external service like an annotation vendor. And maybe the wrapper that you wrote wasn't calling view.export, it was calling view.annotate. And what you're trying to do is send data in your current view according to some configured custom input off to the annotation vendor. All of that is possible within the operators framework. And by the way, in that particular case, since the code basically exists to do that today, we might as well have had that instead. You can expect to find a new operator hit the 51 plugins repo for that particular workflow, and likely become a built-in operator in 51 so that you can open up this, type annotate, and send data off for annotation. So bringing us home real quick, I saw some Q&A happening in chat. Thanks to Richie for supporting that. If you want to get involved in the project, take a look at GitHub. You could search for good first issues as an example, and we would love to help support your efforts in contributing. Again, everything I showed is open source. The main 51 project is open source. The plugins are in an open source repo. VoxelGPT is in an open source repo. So if anything that we covered is interesting, do check it out on GitHub. Give us a star if you're so inclined, and do reach out.